Very good afternoon, students. Once again, I welcome all you on my channel, Be Mathlete. As we are going to encompass the intermediate mathematics, that is 11th, 12th science mathematics. And besides this, we will be overlooking mathematics of Olympiad, MTSE, NTSE, some Vedic mathematics topics, and some banking topics related to time, distance, the proportions, ratios, the work and time. So entire these things we will learn. I'm going to focus on these topics in my coming videos. At this moment, as we have started a very important chapter of mathematics, that is differentiation, and in last video we have overlooked the derivatives of some basic trigonometric functions. After that, derivatives of logarithmic functions, derivatives of exponential functions, and what is the meaning of differentiation, what is the derivative, what is the relation between differentiation and integration. Okay, all these things we have seen in the previous video. So in this video we are going to see the upcoming part of this differentiation chapter, some important theorems on differentiation, and some tools to find out differentiation of given functions. As in last video, I have already explained you the first principal method. What do you mean by first principal method? Okay, this is the method we generally use to find out the derivative of the given function. Here f of x is a function at point x is equal to a. Okay, so this is the method, this is a formula to find out derivative of the given function with respect to x at a given point. This dash this dash represents first ordered derivative. It means f of x, the given function, has got differentiated one time. Okay, if here are two lines, then it means double dash of f of x. It means f of x has got differentiated two times. This is a formula where h is a small increment in f of x. And with respect to differentiating f of x with respect to x, with respect to means what? Suppose we have assigned a task to find out temperature of particular place, particular city. Okay, so we will note the temperature after every 1 hour. We will start measuring the temperature at 12 o'clock, then at 1 o'clock, at 2 o'clock, at 3 o'clock, 4 o'clock, and 5 o'clock. We will get temperatures and we will keep these readings. Okay, so at 1 o'clock we will be having different temperature, slightly change in the temperature what was at 12 o'clock. The same way we will get temperature at every hour. So we have recorded the temperature of particular place with respect to time. Okay, time concept, the concept of time is at the center. Okay, we can say that temperature of particular place is this and this with respect to time at that time. Temperature of particular place is this at that time. So at that time is with respect to. The same way here the function f of x is getting differentiated with respect to x. So the derivative of the function at point x is equal to a, at point x is equal to a, is by using first principle method. So we are replacing x by a. So this f dash of a will be equal to limit h tends to 0 f of, here is x, so this x will be replaced by a, again there is x, so this will be the derivative of the function at point x is equal to a. Got it? So now in the next part we are going to deal with the rules of differentiation. There are certain rules of differentiation those rules has to be followed while differentiating any particular function. So the first algebraic rule is regarding addition and subtraction of two functions. If y is equal to u plus v, then what will happen while we will taking derivative of y with respect to x? Derivative of y with respect to x is dy by dx. So first function is u. So first of all u will get differentiated with respect to x, then v will get differentiated with respect to x. Now if y is a function which is a subtraction of u and v, then differentiating y with respect to x, we will get first of all differentiation of v with respect to x, then this minus sign will continue, then differentiation of v with respect to x. It is very simple. If y is a combination of the two variables, okay, that are u and v, y is equal to sum of u plus v, then differentiating y with respect to x, we will get dy by dx is equal to, will carry the same, differentiating v with respect to x will give us du by dx, and differentiating v will give us dv by dx. It's very simple logic. If there is a plus in between u and v, then we will get plus in between du by dx and dv by dx. The same case will happen for if y is equal to u minus v, then dy by dx is equal to du by dx minus dv by dx. Now in third case, if y is equal to the product of two dependent variables u and v, it's very simple. If y is a product, in previous cases y was equal to u plus v, then this will happen for its derivative. If y is equal to u minus v, then we will get the derivatives of u and v and then minus in between them. In this case now y is a product means multiplication, y is a multiplication of u and v. While differentiating this y with respect to x, in the left hand side of the equation we will get dy by dx. Now this is a product of the two, so this rule is called as product rule. Which rule? Product rule. It is dealing with the product of two dependent variable u and v. So this rule is called as product rule. So what will happen in this case? First of all, we will take first function as it is, u as it is, then derivative of second function plus second function, then derivative of first function. Okay, first function u dv by dx plus v du by dx, and this rule is called as product rule. Now if we have y, fourth case, y is a quotient of the two u and v. In this case u and v has come in the division. If y is equal to the division of u by v, while differentiating this y with respect to x will give us second function, or what we will say, a function which is in the denominator. A function which is in the denominator will called as a function which is in the denominator will called as. So what we will do, the function which is in the numerator, we will say it as a first function, and the function which is in the denominator, we will say it as a second function for our sake of our convenience. So second function, derivative of first minus first function, derivative of second, and this rule is called as quotient rule. This rule is called which rule? This rule is called as quotient rule. Okay, it is very simple, isn't it? So what is this? This is nothing but the algebra of derivative. Algebra means addition, multiplication, subtraction, and division. In this case, the first two are very simple. If plus is there, then we will get first derivatives, and then we will get addition of that. If minus is there, then we will get first of all derivative of u and v, and then we will get minus in between them. Now we need to just do one thing. We need to here keep in mind this third and fourth only, because these two are very important. I will say these are the fundamental formula of the differentiating derivative. Okay, if product is there, then that rule is called as product rule. If division is there, then that rule is called as quotient rule. For product, first function derivative of second plus second function derivative of first. For quotient, first function derivative of second plus second function. For quotient, second function derivative of first minus first function derivative of second. So this was regarding the fundamental rules of differentiation. So till now we have seen the meaning of differentiation, the derivatives of some basic trigonometric function from sine, cos, tan, cot, sec, cosec, then derivatives of exponential function e raised to x, a raised to x, then derivative of logarithmic function log x. Now today we have dealt in this lecture, in this video, we have dealt with the basic algebra of differentiation. Now in the next video we are going to deal with very important theorem of differentiation. So that is nothing but the chain rule we are going to see. This is related to composite function. Now before dealing with the theorem of composite function, let me explain first of all what do you mean by composite function. Here the word itself is expressing its meaning. Composite, it comes from the word, or it reflects to the meaning of combo, or we may say combination, isn't it? Combination of what? Combination of functions in between each other. Like see, we as we have seen exponential function a raised to x and e raised to x. We have seen derivatives of logarithmic function log, say x square or x cube or x raised to n. So in composite function, one function is combined in another, isn't it? This is outer function, this is inner function. And in the latter part of this chapter you may see one more function inscribed in the 2, isn't it? So the combination or the combo of two or many functions with each other is called as the composite function in simple language. If you will see the mathematical definition of that, then that is quite clumsy. See here, log, after that tan, after that a raised to e raised to x. See, at outermost there is a log, in that tan is inscribed. It is a trigonometric, it is a logarithmic, it is a trigonometric, its angle is this, but again this is an exponential function, and in its power it has e raised to x. So such kind of functions are said as composite function in simple language. So in the next lesson we are going to see how to differentiate, how to composite So to learn this, we need to learn chain rule. What? Chain. So see, if you'll see, there is a chain. Outermost part log, it is chained with tan, it is chained with a raised to x. Okay. So a theorem dealing with chain rule that we will see in the next video. So the brief view of today's video is almost this in front of you, and one thing I want to convey to my students that besides video you will get the PDF of whatever I have taught in my lecture, so you don't have to rush up for your note, you don't have to rush up for writing the whatever I am writing here. Okay, so you will get PDF of that, and you can download or you can get printout of that very easily. Think what you need to concentrate, that concept learning is really very, very important. So today the last point was chain rule. So this deals with the composite function. To differentiate composite function, we need to understand chain rule. So its theorem, friends, we will see in the latter part of video. So till if you have not subscribed my channel, please subscribe it, and please convey this or share this with your friends, those are needy, so we can really spread the knowledge, and that will help that needy person. So thanks a lot. We are going to end here today.